All right. Good morning, everyone. Welcome to another great Skillshare webinar series hosted by the National Center for Pavement Preservation in the Midwest Partnership. What you're seeing right now is a poll. If you wouldn't mind taking a quick moment and please select the option that best fits. It's always good to know who we have in the room. So thank you. Also, before we get started, I would like to take a moment and say thank you to all of our active and retired servicemen and women. Thank you for your service and all that you do. My name is Rob Green. I am with the Michigan Department of Transportation. I'll be your host this morning. Our moderator is a good friend of mine, Phil Ruffus from the Missouri DOT. Before we get started, I wanted to share a couple dates with all of you. This particular webinar is our last webinar for 2023. We try to do these quarterly, and as we know that we're butting up against the holidays, don't want to try to compete with those activities, so this will be our last one for 2023. However, starting in January, the Midwest, we are going to start a new forum again to try to increase our outreach and discussion with everyone, and that is our roundtable discussion, and that is going to be Thursday, January 18th. The plan is everybody who had registered for this webinar and those of you who attended the national conference down in Indianapolis in September, we've got your contact information. Someone from the Midwest will be kind of reaching out and soliciting some discussion questions. And then again, the goal of these roundtables is, everybody will have the opportunity to have the mic, and we can share questions that are out there and have an open dialogue, open discussion, get your questions, have an opportunity to ask some questions and hear what others are doing across the country. And then last but not least here, we've got our next Skillshare webinar is scheduled for Thursday, February 15th, 2024. So please feel free to throw those on your calendar. Before I turn it over to Phil, just a reminder, if you're new to our webinar series, what we like to do is a panel discussion. So we've got a fantastic panel for you today. You'll hear a short 10 to 15 minute presentation. They're going to be fairly high level, but the point of it is to kind of start introducing you to some of these topics, dive down into the weeds a little bit, but the idea is to generate discussion and questions. Please use the question pod on the sidebar to enter your questions at any time. And then as each presenter finishes their presentation, like I said, we will then use the remaining time to open it up as a panel discussion. So with that, I am going to turn it over to Phil.
Thanks, Rob. As Rob said today quite perfectly, the way we usually do our webinars is start from a technical angle, give you some background, and then finally, the last speaker will be more of a practical application. Our first speaker is Aaron Roy. Aaron Roy comes to us from Nurion. Aaron is currently an account manager dedicated to growing revenue through technical solutions and expertise in the surfactant market. He has 10 years of history with both technical and commercial roles within the asphalt leaders, including leadership, P&L responsibility, and sales. Aaron is a passionate problem solver through many formulation development and troubleshootings to balance customer and his company's needs. Aaron?
We can't hear you, Aaron.
Yeah, sorry. I think I was waiting for the poll to get through to do the presenting mode, and I was trying to figure that out. Like he said, I'm Aaron Roy. I work for a chemical supplier, but I've been in the asphalt industry for a decent amount of time. So I'm here today to talk to you a little bit about chip seal and kind of talk a little bit about polymer modification within chip seal. kind of high level, talking about polymer versus latex, what the difference is, and then Arlis is going to follow me, who has a lot more experience and expertise in this subject for sure, and talk a little bit about some actual field data and field applications. And I am an engineer by background, so if I get too far in the weeds, Rob or somebody needs to smack me and get me back up to the high level, so I'll ask them to do that. So first off, we're talking latex versus polymer modification. I think we have to start with what is latex versus polymer. Now, I think I can do a laser pointer, but so they all contain styrene and butadiene. So up here, we're talking about latex. Now this ends up being a water-based polymer dispersion product. And we're talking about styrene, that's this little thing here. I'm not gonna get too deep into the chemistry, but it's got this big old chunky thing here, and that's gonna give you some strength. And butadiene is gonna give you some flexibility. Now this is a reaction, and it creates sort of a randomized sequence of styrene and butadiene. And the reason why it's called SBR rubber is when that comes out of this solution, it kind of has a rubbery aspect to it. But the two different polymer systems do have the same main building blocks. In the polymer-based system, the difference is the styrene, butadiene, styrene is in some sort of a sequenced rotation. And while this comes out as a rubbery aspect in final situations and is a liquid when we're processing it, this comes out into more of a solid kind of styrofoamy little pellet with actually two different glass transition temperatures. So these are different products. But first, talking just at a high level, how do we get SBS polymer that we're talking about, this solid little pellet, into asphalt in the first place? And this applies not just to asphalt emulsion for chip seal, this also applies to hot mix binders and situations. So we've got this solid material here. We've got asphalt binder. Theoretically, given enough time, it will be digested into the asphalt, but we really need typically to use a mill that kind of grinds that polymer into the asphalt binder to get to a situation that you like. So these are two slides just from a mill manufacturer. This is a common screening tool just to put the material through a screen. And you're seeing chunks there, and you're seeing a situation here where it's not fully dispersed into one phase. So this is really what we're looking for. We're looking for that polymer to be fully dispersed within that asphalt. So it's one continuous phase of polymer linked with asphalt binder to give you one solid system. So just touching a little bit on what asphalt emulsions are and how they're produced. So a similar mill kind of concept, but you take asphalt binder or bitumen, according to this, and you mix it with some kind of soap solution. Now that soap solution would have an emulsifier, which is something we work in, maybe an acid, maybe a base, maybe some other chemistries. Those all come in line and get emulsified. Those asphalts get turned into small droplets, and that gets turned into an asphalt emulsion. And in the case of pre-modified or SBS modified, nothing really changes on the general schematic of how that's made. This asphalt binder is just a different system. But in the case of latex modification of the finished emulsion, this is another liquid. So this is a water-based polymer dispersed system. So this can be introduced a number of different locations within the system, but it is compatible with water. So it's typically introduced into the soap line or even into the soap tank. And it mixes well in and really doesn't add a ton of changes to temperatures and everything like that, like we'll get into. So what does it look like when we have this latex modified system? Well, in the end, it's a mix of two different dispersions. So you have these asphalt particles that were milled up by that asphalt emulsion mill, and then you have these latex SBR particles, those styrenes and butadienes in here. And these are two different systems mixed together. Now there's some different methods on how you can do that. You can do it in the soap, like I said, or you can co-mill it in various different ways, or you can post-add the latex and mix it all together. There's all kinds of different polymers. SBR, as we touched on in the beginning, is the most common. Natural latex existed at some point, and neoprenes are out there too. Generally speaking, and we'll get into this a little bit more, you're gonna have a lower asphalt viscosity compared to SBS, whereas SBS is gonna increase the viscosity of your asphalt in general, and the latex will also have an impact on the rheological properties of the finished emulsion. But what's important, really most important to understand here, the polymers that we're talking about, these styrene butadiene polymers, are in the water phase. They're not in the oil phase. They're in the water phase. These are two separate systems combined together, and then you get your end properties once everything breaks and you get your final chip seal. And then on the polymer modified system, these are just the same as any other asphalt emulsion system. You just got all the droplets of asphalt, but within those you have these links of the styrene butadiene styrene copolymers within the asphalt droplets themselves. So the asphalt binder was pre-modified with polymer, so the polymer exists in the oil phase or the asphalt phase. So due to this, you get a higher kind of viscosity or shear resistance going into the asphalt emulsion mill. So this binder becomes more difficult to emulsify compared to a standard binder that you would use with the latex system. So not always, but sometimes this requires you to exceed the boiling point in order to make a high quality asphalt emulsion with these systems. So that could lead to an exit temperature above 100 degrees and the need to use heat exchangers and back pressure and everything like that. So this adds a complication. The overall schematic is the same, but it adds a complication in terms of it being more difficult material to mill. Whereas if you introduce latex, the material that you're milling when it comes to an asphalt is the same as it would be for a CRS2 or any standard emulsion. So there's some different options on how you add the latex to the asphalt emulsion system. So this is probably the most common that I've seen, at least. So you've got your typical setup here, and note these temperatures here. We're not going to exceed the boiling point. We're kind of just making a regular emulsion here. You've got your soap solution with your emulsifier and everything. Now you can batch the latex into the soap tank or add the latex in line to the mill. So that's very common to see setups where you have either a tote of latex or a tank of latex, and then that's just going in line, maybe a static mixer here, and then it goes to the mill, and basically nothing else changes. You've just got that system of polymers dispersed within your asphalt emulsion when it finishes. So when you add this, one thing to note is latex does have some salt in the system. So if you made a CRS2 or whatever regular version, changed nothing else, and added latex in the system, your viscosity will go down slightly, but it actually becomes more stabilized. And the reason for that is something back in high school chemistry called osmosis. So the water will flow based on salt levels. So you kind of shrivel up your asphalt particles a little bit because the water flows out of them. Another option, and if you ask Arlis about this, he'll strongly encourage against it, but it does happen, is to post-add the latex to the finished emulsion. So you make a finished emulsion, and either in your batch tank or your finished tank, you put in some latex. The problem with this, and why this would never be done in a chip seal application, is doing it this way will greatly reduce your viscosity, because that osmosis effect will be more pronounced and more localized as you're able to mix that latex in. So you'll lose a ton of viscosity in that situation. And if anybody knows about chip seal, viscosity is very important. And then the final option is to actually inject the latex into the asphalt line. So what that does, and what people have found, is that will significantly increase your asphalt viscosity. So the reason for that is it kind of encapsulates some of that salt water. So it actually swells the asphalt particles slightly to increase your viscosity. Now, one thing to make sure we understand is the polymers themselves are not going into the asphalt droplets. The polymer is still a separate system. We've still got two different systems. You're not accomplishing that, but you are accomplishing a change in the rheological properties. So what some people will do, like you can have one line of latex and do part into this asphalt line and part into the soap line, and have that be a way to adjust your asphalt emulsion viscosity without having to start playing around with emulsifier content or asphalt content. It's kind of an easier lever to use to adjust viscosity, and I've used it in the past in my career, and it's easier to change that because if you start changing asphalt content, you're changing your general design of the system. You start changing emulsifier content, you're changing the way everything reacts. So it's sort of an easier way to adjust for viscosity. So how are these systems tested? Historically, it's always been, I started off in the lab, and you do the very high temperature asphalt emulsion distillation method. So, and it's funny because, a couple of weeks ago, I actually did not the same slide, but a similar kind of presentation in front of some real polymer scientist experts. And I was like, yeah, sometimes we distill it at 500 degrees Fahrenheit and their eyes got this big. And then I even said, well, sometimes we work on it, we bring it down to like 350 or 400, and their eyes, and they're like, that's still not great. So some of these testing methodologies are really exceeding the temperatures that these systems ever actually see in the real world. And they're also doing some level of polymer degradation and reaction and stuff, But really, the main thing to me, and this is even back in the beginning of my career, I'm like, well, when we do a chip seal, the road never actually gets this hot ever. So what are we really seeing? But the goal with the test, the distillation test, is to make sure you have all the water out. It's actually difficult to get all the water out of an asphalt emulsion. You can get the initial water out, but some gets encapsulated in the oil. Is to get all the water out, all the oil out, measure the oil, and then know that all you have left of that residue is the binder. So it's kind of a way to get that done. Now, there's been some movement to kind of improve some of those recovery methods lately. And one of those was the a vacuum kind of distillation. So you can lower the temperature and use a vacuum to kind of improve the way that performs, but it's kind of cumbersome. You've got to get a whole new piece of equipment. You got to have something else to work with, and who wants to deal with that? So how do we remove the water without damaging the polymer? Well, and I'll get into this on the next slide, there's some current studies moving towards some new recovery techniques and some new methodologies that don't do that. But what do we do once we have this residue? The most common historically is what's called the elastic recovery test. So you just basically, if you take a ductilometer, you stretch that material, you let it sit for some amount of time, you cut it, you see how far it recovers. You know, if it recovers over a certain amount, you've got polymer in the system. And then you have typical pen, softening point, all that kind of stuff too. This is kind of representing where things are moving in the future. So you can just Google NCHRP 963. It's been going on for quite a while. One piece of that is to move to a more realistic residue curing method. And then the other is to start using the dynamic shear rheometer, get some numbers, and they're working to correlate that back to actual field values. Because one thing I wanted to touch on the first slide, chip seal is very important to understand we're talking in the pavement preservation group. This is a preservation treatment. This is not a structural treatment. It's more along the lines of a membrane. And some of this testing historically has been designed more for your real load bearing capacity increasing hot mix. So we've got to be careful on how we analyze these systems. So what does that residue actually look like? There is a difference in how the residue ends up looking like between a polymer modified asphalt system and a latex system. So this is how it would look theoretically, just neat asphalt. You just got asphalt rheology. In a latex system, it actually is a membrane of polymer between the asphalt particles. And then in an SBS system, theoretically it coalesces back together and you get back the SBS properties. Now, what do these polymers do? They improve low temperature fatigue. I think everybody in DOTs knows what polymers do theoretically. They reduce rutting, they improve early strength. But really for chip seal, we're not talking about, I mean, maybe low temperature fatigue, but we're not really talking about rutting. It's a membrane. So what do polymers do for us in terms of chip seal? Well, I would say the biggest, at least in my career being field QC and different things like that, the biggest failure modality of chip seals is stone loss. And it's been proven, and Arlis is going to get into some of this, that polymers give you that nice little stretch, that additional adhesion, and reduce, assuming your mix design is correct and your application rates are correct, reduce that stone loss. So we don't get things like this. We don't get things like all the stone is off and then we've just got a slick asphalt surface, because the goal is to have some stone and then have that nice membrane to preserve everything that's underneath it. And there is one way that we work on to test that, and that's called the sweep test, which is ASTM D7000. We just kind of take some roofing felt, put some asphalt emulsion or whatever the binding agent is on there, put an appropriate application of rocks on there, cure it for some amount of time. So this can be used for two different things. You can cure it for different amounts of time and see how it's performing in different curing environments, or you can fully cure it and see how it ends up performing in the end. So what are you testing with that? You're testing the adhesion. So there's some chemistry going into that, the reactivity, how this system clings to the aggregate, the overall durability of the system, and the binder property. So you take this specimen, and this is kind of just, it's actually like a baking, just a mixer, just goes in a planetary motion. It's used a lot in micro too, but you take that specimen, you put a brush over top of it and water, and it just rotates around and you see how much stone you lose by beating it up. So you lose a little bit of stone, less stone you lose, the better your system is. So that's really all I had. I'm going to hand it over to Arlis Kadrmas from BASF, and thanks.
Thanks, Aaron. As we look at our second poll, go ahead and take a couple of minutes to go ahead and click that poll as I start to introduce my friend Arlis Kadrmas from BASF. Arlis is an expert technical specialist currently at BASF Corporation. Arlis has worked on the development, implementation, and commercialization of asphalt emulsion products used in surface and recycling of roads. Arlis is a known expert in the field and currently holds or is part of 19 different patents throughout her storied career. Arlis?
Thank you very much. Appreciate it, and appreciate the opportunity today. And I think Aaron introduced the processing and how the latex modified versus a polymer modified emulsions are made. And I want to get into a couple of the comparisons showing whether you run an SBS modified emulsion as a chip seal or an SBR modified emulsion chip seal. They can both perform very well, be very comparable. And I've got a little bit of data that shows to kind of expand upon what Aaron had mentioned, and just have one project that was done as a trial that compared a latex modified chip seal versus an polymer modified emulsion based chip seal. So to start out, I just wanted to show you, and again, kind of expand upon what Aaron said about elastic recovery. It's one of the tests that a lot of agencies use to kind of define whether a polymer's in the system. And on this particular elastic recovery, polymer A happens to be a latex modified system. Polymer B happens to be an SBS, basically a polymer modified asphalt made emulsion. And when you look at, one had a little better elastic recovery. When you look at the sweep testing that Aaron kind of focused on a little bit, and again, just showing those results, you can see that even though polymer A had a lower elastic recovery, it held the chips a little bit better with this particular chip and this particular design than polymer B after 2 hours. A lot of agencies are trying to get the brooms on, get to sweep the excess chips off the road to get traffic back on the road. And usually the sweep testing is done at normal road conditions. This one happened to be 35 degrees C, which is slightly under 100 degrees Fahrenheit, which, obviously a lot of pavements that chip seals are applied on are in those temperature ranges. So looking at this after 2 hours, the chip is holding fairly well. With both systems, the polymer had to be a little better with this design with that system. So you can take a look. Just taking a look at 1 hour mass loss. This is basically the emulsifier itself hadn't fully broken, hadn't cured, and done basically what Aaron had showed about the coalescence and grabbing onto the chip. So in 1 hour, they both still hadn't built up that strength. And this is just showing how the sweep test can kind of show you how these systems work. My next slide, I want to get into a comparison of this is using a latex modified system with SBR with 8 different aggregates. This data was done by Paragon Technical Services, so I appreciate them for this information. What this is basically showing is how good polymers can make a system and make them perform better. Usually on a sweep test, you want to see above 80% chips retained. And the first 3 aggregates without polymer modification were slightly above that. One aggregate A actually did fairly well, but all of them with the addition of polymers helped out systems that weren't very good. You can see samples D through G had right at 70 or so percent loss, but when you added polymers to the system, this just shows on the slide that Aaron showed with the chip loss that you can get great performance out of these materials by adding the polymers to the system. I want to expand again. This happened to be data from a project where they did do a latex modified and a polymer modified system. Just shows you, oops. I think I lost my screen.
We're still seeing you fine.
Okay. Sorry. I lost my view of the Okay, thank you. The last recovery on here, this happens to be 2, and you can see that they're very similar results, whether you used a latex modified system or an SBS polymer modified system. Expanding on a little bit of what Aaron said, how things are moving toward low temperature evaporation procedure. This just shows the data from the same project where you can see comparable data. As far as G-star, you can see a little higher. Almost always the latex modified system will have a little higher phase angle when you do a low temperature evaporation. That's something that is being looked at in the systems, and when it comes to try to specify under the low temperature evaporation procedure, they're looking at a lot of different ways of trying to specify around it. But I just wanted to put this slide up there to show you that this is being done, and there is some data that it is going into this process. I wanted to, lastly, the few slides that I have left, I wanted to show you an actual field application that was done in Crater Lake, Oregon, where this process was done with both a latex modified and a polymer modified base chip seal emulsion in the field. This was done by Central Federal Lands, and the project was done really, the reason I've been talking about sweep tests a little bit is this project was done to focus on how good the sweep tests could be, and I'll expand on that a little bit. But just on the emulsions that were used on this project, it was obviously done many years ago, and both of these products have been performing very well. The CRS2L, the latex product, you can see some of the data on it. They ran torsion recovery. Basically, that was kind of how that emulsion was spec'd at the time. It performed very well on that test. The CRS2P, the modified asphalt-based emulsion, had again met the specifications for the project out in the field. And this is just, again, comparisons, expanding a little on what Aaron said. Both of them had about the same viscosity, so you can make the emulsions. The residues are about the same. So again, the emulsions can be made very similar. Again, the project was done, and the reason this comparison was made is the sweep test was starting to really get looked at in a lot of labs, and they wanted to see whether it could be developed into a procedure that could go into some specifications. So that's basically what this slide is about. There were 4 laboratories that were involved in some of the analysis behind some of the sweep testing, just to give some data and some information. This next slide just basically shows some of those sweep test results. And on here, what you'll see is that whether it was a 2L or 2P, if you look lab by lab, the results are very similar. And that's basically what I want to focus on. The results are very similar. The reason that the sweep test hasn't been kind of grabbed and put into specifications is you can see that by this slide. A lot of suppliers are using it in a design process, and it works extremely well. But interlab, if a lab is using this particular procedure, it works very well and they get very consistent results. But if you look at the interlab reproducibility, it's not very good. You can see the results range from about 4% up to 20%, and they're not very good. But what this slide does show you is that the latex modified system or the polymer modified system are perform very similarly if you look at the laboratory by laboratory setup. This next slide, I just wanted to show you particle size and emulsion. Aaron kind of got into how the production was. Basically on this slide, just wanted to show that both emulsions, whether they're latex modified or a polymer modified base made into emulsion, give you stable emulsions over a period of time. So these results are just taken a couple of weeks apart. Basically, the particle size are basically one right on top of another. So basically, this is just saying that no matter how the emulsions produce, that they're fairly stable over a couple of week period of time, which is very important. In the application itself in Crater Lake, they saw no differences in the performance between the 2L and the 2P, how it shot, how they had to roll it, to seat the aggregates, there were no differences. And my last slide in the project evaluation, Mike Wolf was a Central Federal Lands person that was in charge and looked over this. They had evaluated this project over a period of time after years, and it showed no differences in performance at all. And so what I wanted to show and pick out this particular project, and there are many agencies that use and can spec both CRS2L and CRS2P, and they see no differences. But I wanted to focus on one particular project, and that was done in a federal agency area that showed that both of these can produce very good results. So with that, I think I'll turn it back over to the next presenter.
Wonderful. Thank you for your time. As we look at our next poll, I will once again ask, if you've got the time, especially right now, what are some questions you might have generated by the two presenters we've had previously? As Rob mentioned earlier, one of our missions is to kind of get a back and forth about stuff that you didn't know to ask. And as mentioned, I will be gathering all of these and then accordingly asking them at the end of the final presentation. So having given you some time, our next presenter is Bobby Betsold. Bobby currently is the Director of Marketing at All States Material Group in Massachusetts, having previously led that technical side of the house for many a year. Bobby's going to move us in a more practical manner as he begins his presentation. Bobby?
Thank you very much. I'm just trying to get the presentation up here. You able to see that?
We see it fine, sir.
All right, perfect. So thank you for the opportunity to be here. I'm going to move again a little bit off of the technical and more into field application and talking about different really materials now. We're looking at asphalt rubber chip seals. And first, before getting into specifics on the asphalt rubber, really wanted to hit on hot applied chip seals as a whole. So to the outward appearance, hot applied chip seals will look like an emulsion chip seal. It's really the big difference that comes from the materials being used. And primarily that is, instead of the use of an asphalt emulsion, we're using a hot binder. In the majority of cases, it's one of three options that may be getting used. The first would be a performance graded asphalt, which could be modified or unmodified. The second being rubber modified asphalt, which is commonly referred to as terminal blend, where we're looking at typically a 5% or so rubber. And then the third being asphalt rubber binder. And with this, I note, the differences between the second and third options there sometimes can get confused and can be used interchangeably, but are differences between. So typically the asphalt rubber binder is referred to as the wet process, where we're looking at a greater than 15% crumb rubber that is added in. In all of these cases, as will be discussed in some of the reasons why, we typically also are using pre-coated aggregate. And the main reason on that is with the heat and the hot applied of the binder, we really need to have aggregate that is both clean and dry because of the temperatures that are being applied out there. And whereas the emulsions and going back into the days of cutbacks, you are allowed to kind of get away with some dirty or some damp stone. And in many cases, a little bit of that dampness actually would even help. With the hot applied process, you really need to have that clean and dry. So that's where the pre-coated aggregate, typically with a PG asphalt through a hot mix plant, is utilized for all of the hot applied chip seals. As far as specifications, there is a specification out that was published in the interim AASHTO 2022 revisions, section 407, specifically related to hot applied chip seals. Also, the emulsion specifications were updated in that same revision. But these go through for each of the different materials, the typical application ranges, which you can see there and that. Again, starting with the PG asphalt, which are a little bit lower on the application rates, both on the liquid and on the aggregate, and then working up through the rubber modified asphalt and into the asphalt rubber binder. For all of these, when it comes to the construction process and what's done out there, again, very similar outward appearance to what you see with the emulsion-based chip seals. So you've got a distributor spraying, you've got the chip spreader applying the aggregate. The rolling application that follows is again very similar. And the big difference when it comes to the hot applied is, in most cases, the sweeping follows immediately behind the rolling operation. And a couple of reasons in that regard. The main one being is, without the emulsion, without the chemistry and the curing time for the water and the evaporation, hot applied chip seals are a thermal set application. So essentially similar to hot mix asphalt, where you have a temperature and it really is driven by the temperature. So once that binder cools and everything is there, that chip seal is set. So that's what allows that immediate sweeping right behind the rolling operation. So moving now from the hot apply to the high level, the rest of my presentation is really going to focus on that third option there, that third binder, the asphalt rubber binder, the wet process as it is called. So when we talk about asphalt rubber and why you're using asphalt rubber, and this actually pertains not just to chip seals, but also looking to why use asphalt rubber in hot mix or in other binders in general for different paving applications. You can see there are many of the benefits that come through, and it really relates to getting into a lot of the chemistry that's involved and what it allows in terms of increase in performance and increase in the ruggedness of that binder that's out there. We're based up in the Northeast, do a lot of work in the Northeast in cold weather climates, and when you look at freeze thaw and flexibility and those types of issues with chip seals, the asphalt rubber really does beef up that binder and the performance of that chip. With that, you're getting your longer service life, and as a result, your equivalent annual cost and the performance start to become more beneficial as well. Also allows you to stretch in placing the treatment onto more demanding situations, higher traffic counts, and along those lines. And then obviously with the sustainability side, so on a typical mile of roadway, 24 feet wide, you're typically using around 1,350 recycled tires in that. So certainly, again, looking from a recycling standpoint, to get that rubber into the chip seal as well is certainly a great thing. Talking a bit about the specification for the binder and the wet process. So again, as I mentioned, it is a blend of a minimum of 15% chrome rubber. This is done according to ASTM 6114. Type 2 is specifically the binder specification for this. And a couple of key points that come off of this specification, as are noted there, really in terms of that blending process. And I'll show on the next slide a couple of different options in terms of the blending. But it's a mechanical blending process that is similar but a bit different from blending polymer modified asphalt. In that the asphalt rubber is actually suspended, so it doesn't get fully absorbed or brought into the asphalt, but is actually suspended, and you can actually see the particles, the fine particles, typically a 30 mesh of the chrome rubber that are suspended in there. But there is a period of time that is required for the heating and the agitation and the reaction process so that you actually get the swelling of those particles. And without that, and without meeting those requirements, the performance really does get impacted. So it's critical to follow that process in terms of the reaction as laid out in 6114. And then from there, continuing along with that heating and agitation once it goes to a job site. So once it's blended, all of your transfer vehicles, all of your distributors all need to have that heating and agitation to allow that asphalt rubber, to stay suspended within the asphalt. So as I mentioned, these are two typical applications when it comes to the blending operation. So on the left-hand side there, that would be a setup where it can actually be blended on-site at the terminal. So and this could be, this terminal actually specifically can be used for polymer or for asphalt rubber in terms of milling it in, using that there. Or it can also be set up off-site using a portable blending operation, a portable blender. Regardless of which process is used, The biggest key on that is, again, going back to the specifications and that strict quality control to make sure that you're getting the performance out of the materials that you really need. Along those lines, and this is a big part of the new specifications through AASHTO when it comes into really trying to raise the level of our pavement preservation treatments and our materials up to the standards of hot mix and really bring the quality control up with that. So with that, all of the asphalt rubber binder goes out with certification. So there's sampling and testing that is done for every lot at the point of manufacture. You can see there, everything in terms of meeting the requirements for ASTM D6114, certifying that the test results and all of the specifications are being met. And this, again, just tries to raise that level, giving us the quality control, the quality assurance on the materials to minimize the variables that we know. So, really try and make sure that we're getting the best performance out of our product when we get out onto the road. From a process perspective, as I mentioned earlier, outward appearance very similar to what you would see with an emulsion-based chip seal. Surface prep and cleaning, as always, for pavement preservation treatments is critical. In the case of hot applied chip seals in general, and certainly with the asphalt rubber, a clean and dry surface is critical. So the same way we need to have that clean and dry aggregate, we need to make sure that we have a clean and dry surface. So where with an emulsion chip seal, you can get away with a damp surface. You certainly need that dry surface for any type of hot applied. Otherwise, you really can't get the adhesion down there with a hot binder. You have a hot spray application, in this case, 325 plus, and typically around 0.6 of a gallon. Again, the national specification calling for 0.6 plus or minus 0.1. And then the placement immediately behind, similar to emulsion chip seal, of the cover aggregate. In this case, again, remembering that it is a heated and pre-treated cover aggregate. You have the sweeping, or the rolling and the sweeping that will follow. And in the majority of cases, normal traffic operations are returned within 1 hour. And the goal in many cases is to actually never have traffic onto a surface that hasn't already been swept. Certainly not always capable, but that is typically the goal with the hot applied, because you're able to sweep it immediately. This process is also, because of the flexibility that's added in, is used in many cases also as an interlayer. So process-wise and material-wise, placed exactly the same, except the difference is that there is a surface put over it, typically a hot mix or paved surface that is used. What you get is you get a thick layer that can really absorb a lot of that reflective cracking and seal and waterproof the surface. In the case of those two cores there on the right-hand side, that was out of Massachusetts, and a project where they had an area both with and without the interlayer. These cores were taken 2 years later. You can see with the without interlayer, how that crack had reflected back up through. And with the core on the right-hand side, the line there where the rubber chip seal was used as the interlayer, that has really absorbed the cracking and the reflection coming up through, and has deterred and delayed that reflective cracking coming up through the surface layer. Just to show a couple of kind of completed projects, what they typically look. Another note, and then that's very visible in these photos of the completed projects, is with the heated and treated aggregate, you do get a much darker surface, especially immediately with the application, because of that coating on the stone. So it provides that higher contrast when a stripe goes out. And there's also a certain degree of perception when it comes to the driving public of being on a darker surface road, as opposed to with the untreated aggregate of whatever the color is, whether it be the gray or the lighter. These are 3 examples of DOT projects on mid to higher volume roadways. On the municipal side, again, a couple of examples. More in a rural setting on the left-hand side there in New Hampshire, Newport, Rhode Island, right along the ocean, and then Arlington, which is just outside of the Metro Boston area in more of an urban area. So placement of the application in a variety of different situations and road conditions and types. I also wanted to put this up. This is actually going to be coming out in the next issue of the Pavement Preservation Journal as a case study. This is in Cape Cod, Yarmouth, Mass. a program that's actually been going for over 20 years. And just to kind of see some of the performance, so that photo on the left is actually an 11-year-old asphalt rubber chip seal, the center a 10-year-old, and then more recently a 4-year-old. So you know, a chance where it really can stretch the performance, stretch the life by utilizing the asphalt rubber in the chip seals to increase where you can place it and also the life that you can get out of it. And then just wanted to close with actually a couple of unique applications and projects that have been done. That left-hand side there is actually a wooden drawbridge in Massachusetts. So you can actually see, if you look close, the lines that are kind of running diagonal from left, bottom left to upper right. Those are actually the wood deck, wood decking on that bridge. So this is a case where the rubber was actually sprayed right onto the wood deck. The center photo is where it was used in an interlayer application, actually on a section of the Boston Marathon route with another pavement preservation treatment. The bonded wearing course is the surface pavement. That was a concrete section of roadway with exposed concrete. And then the right-hand side there, again, another bridge application. This is in Rhode Island, where you've actually got a high vehicle count in excess of 15,000 vehicles per day. So just some unique applications. There is actually another, bridges seem to kind of be some unique applications. There's actually a steel drawbridge in Maine that also has a surface placed on it where the rubber was sprayed directly onto that steel bridge deck. So with that, I will turn it back over for our final presenter.
Thanks, Bobby. So we have one final one as we move on. A final poll. Go ahead and take a couple of minutes, excuse me, a couple of seconds, as we prepare for Shawn Brost. Mr. Brost is part of Vance Brothers Construction, which is currently on the other side of the state. Shawn Brost is currently Vice President of Vance out of Kansas City, having risen through the ranks beginning at road crew. Shawn is a proven leader in the pavement preservation industry, having shared his knowledge base at every level, from the project's crew to the project's management. Shawn?
Thank you, Phil. I hope you can hear me. My screen showing up?
Looking great, sir. Go ahead and put it in presentation mode.
There we go. Okay, thanks, Phil. Yeah, and I appreciate the opportunity to be able to do this. I know, for one, I've already learned something. I would not have thought placing chip seal on a wooden surface was a very good idea, but obviously Bobby proved that can happen. So I think that's pretty interesting. So getting even less technical with my presentation, my goal is to, or I guess my assumption is that everyone here at least is familiar with the chip seal, understands what it is, how it works. Trying to give a chip seal 101 presentation in 10 to 15 minutes is not really practical. So I was going to go over just a few more fine points, point out a few things, kind of adding on to what Bobby discussed, and showing that where you place it matters, how you place it matters, and how all those things can be adjusted for and accounted for the mix design process. You know, just being here in Missouri, the two main states that I personally have worked in, have a lot of experience in, Missouri and Kansas. You know, both of those states have chip seal placed on their interstates, in some cases 30, 40,000 ADT, all the way down to state highways, county roads, subdivisions, cul-de-sacs, you know, everywhere that you can think of, there's chip seal placed in here. I know personally that I annoy my wife quite often driving through when we point things out, or I point things out to her to say, you know, that's a chip seal that so-and-so did, chip seal we did. You can't hardly go anywhere without seeing it. So to begin, chip seal is used in almost every state in America, either at the local, county, or state level, also widely used internationally. Chip seal can be and is used in a variety of applications, includes interstates, highways, signalized intersections, residential thoroughfares, cul-de-sacs, etc. Good news, bad news. The good news is you can place a chip seal anywhere. The bad news is you may not want to. So that needs to be considered. And so what I wanted to get into are the characteristics of a quality chip seal. The first step in the process is site selection. The first step in creating a successful chip seal project is selecting the right road. We hear that all the time with pavement preservation, right road, right time, and chip seal can be placed virtually anywhere, but will only be good as the road it is placed on. The second important characteristic of a quality chip seal is a mix design. A successful chip seal requires correct materials are placed at the correct rates. The design process should include a site visit to evaluate existing site conditions and analysis of specified materials. And the last and final is equipment calibration. Equipment needs to be calibrated to the mix design, and that mix design is a starting position for every application. Field conditions need to be verified to check against site design. Touching back to site selection quickly is like I said, you can place it anywhere. That doesn't mean you should. It's an important step in the process to make sure that you're placing something, any pavement preservation treatment, at the right time. And the mix design is what's going to determine what level, what quantity of materials are placed, and at what rates. And that can change within the project itself. Conditions change throughout. There's a difference between a long straight highway and a intersection that may be have a significant amount of increased traffic on it. And equipment calibration, obviously, you don't know what you're applying if you haven't checked. And so your mix design is not going to be any good if you haven't calibrated that equipment to know that what you're supposed to be placing is what you are placing. So site selection. So chip seal can be used in a wide variety of applications. A large amount of success depends on what is placed on. Expectations need to be managed. Both of these pictures that you're seeing here are areas that chip seal can be placed on. The picture on the left obviously has a lot of block cracking, significant amount of cracking, and the one on the right looks like a fairly newly constructed road. Chip seal can be placed on both of them. I would venture to bet that your results on the picture on the right are going to be better than the results in the picture on the left. That's where expectations come into play. We hear a lot of times of, we're just trying to get by a little bit longer. We want to extend the life of this a little bit more. I need a few more years out of this before I can afford to do something else. And so if you're looking to get a few years out of a chip seal, that one on the left, I'm sure can be designed to get that few years. If you told me you wanted 15 years out of that with a single chip seal, I would probably tell you that you're being a little bit unrealistic. The one on the right, on the other hand, though, you place a chip seal on that, it's going to last a significant amount of time and reduce that overall maintenance cost throughout the life. Again, here, both pictures are examples of quality chip seal candidates. The one on the left there, we do a lot of work in residentials here in the Midwest, where you're chip sealing areas with curb and gutter like that. I hear all the time that if there's curb, you can't chip seal because of the excess chips. And that's not necessarily true. It just requires sweeping and collecting of any excess. In some cases, there are agencies that will sweep up to 4 times in the first 60 days just to make sure that those loose chips are collected and taken off the roadway. Picture on the right, as I said before, both Missouri and Kansas have chip seal on their interstate systems. And so it can be done, and it can be done successfully. There may be a few extra steps that need to be taken to make sure that you're getting what you need to out of that chip seal. So the calibration, having calibrated equipment is essential for success. It is necessary to ensure materials are being placed at the rates determined by the mix design. So that picture on the top right there is an example of calibrating a chipper. That tarp is 3 by 3, 1 square yard. So if your mix design tells you need to be between 20 and 22 pounds per square yard per se. You will place that and make sure that what you're laying is in that 20 to 22 pounds or whatever your computer is set at. That will be repeated all the way across the width of the chipper. If it's a 24-foot wide chipper, you're going to have to do that 8 times, and adjustments need to be made if you're not hitting that target you're supposed to be hitting with that chipper. You know, you wouldn't want a situation where the right side is laying heavier than the left side, you know, or there's a couple gates in the middle that aren't quite opening all the way. You're not getting out what you need to get out. All those things are going to inhibit success in a chip seal application. The bottom picture there shows an example of calibrating a distributor. You'll turn this on. You will see what you're getting in a timing method to make sure all those are even across the board. You can also do your distributor in a similar method, like you see in that top picture there, where lay out a cookie sheet, pie sheet, something like that with a determined area. And then you can weigh to see how many gallons you're getting in that area. And again, repeat that all the way across the bar to make sure it's coming out evenly. So the key features of mix design are the materials being used. The beginning place and core of every mix design is the median particle size of the aggregate. The binder rates are established to achieve 60 to 70% embedment of the aggregate initially. So this can kind of be a little bit of a back and forth in that you can start with the idea that we want to use aggregate A. You know, and you may look at that, and given that aggregate, the mix design will give you a binder rate. You may look at that and think that binder rate seems too small for what we're applying. You know, I want a heavier coat, something along those lines. And then at that point, you would want to go look at potentially a larger aggregate, something that's going to have a larger binder rate with it. And then the surface condition. Relative amount of cracks and porousness of the existing road determine the rate of binder. For example, if you are applying a chip seal over, you know, maybe an existing chip seal road, something that was done a couple, 3, 4 years ago, you need to know that that road is not going to absorb any of that emulsion or extremely little of that emulsion or hot rubber asphalt. It's going to reflect. So that's your mix design. It needs to be input into that. So it decreases the amount of binder you're applying. If not, you're going to end up with a flush surface, something where the aggregate displaces the asphalt binder. The asphalt binder goes to the top. You end up with that black flush, especially in the wheel path look, something that is slick, doesn't have any friction on it, and can be extremely dangerous to the public. The traffic volume and type is a big determining factor in your mix design. Knowing the traffic type and volume is critical. Generally, the more traffic, especially heavy traffic, the rate of binder is reduced. So to kind of go back to that residential street example, you're not going to have a lot of traffic continually driving that aggregate down into your asphalt over the life of the chip seal, whereas you will on something like an interstate where you've got, you know, the 30, 40, 50,000 cars per day driving across that. It's a little bit counterintuitive, but the less traffic, the more asphalt binder you need to help hold that in place. And that goes to example like on an interstate. Your shoulder, if you're doing full width shoulders and main lines, your shoulder is going to require a different mix design than your main line will. They're two different, they may have the exact same road surface, existing road surface to begin with, but the traffic count on a shoulder is extremely low, whereas on the main line it can be extremely high. So those need to be treated separately. You can't treat that because of the existing, you know, the traffic type you can't treat those things as the same. You know, there was a discussion came up, I believe in one of the previous presentations about chip sealing through signalized intersections. You can do that. It can be done successfully, but you need to potentially make adjustments. You know, that turning traffic kind of falls into that type of traffic category. It's not the same as cars running straight up and down a chip seal. That needs to be accounted for. I know one of the things that we've done here for cul-de-sacs, particularly busy intersections, things of that nature, is switch to a smaller aggregate. That aggregate is less likely to roll over than a large aggregate is, and we've had a tremendous amount of success using that, you know, using that smaller aggregate versus something you may want a little bit more robust on a main line where people are just driving straight. And I really didn't have a whole lot else besides that. I was hoping that that might inspire some questions, and would be happy to take any questions and just kind of see what might be in the chat and what we can discuss further. So with that, I'll hand it back over to you, Phil, and I appreciate the time.
And we appreciate you as well as all of our panelists. Now, several of you have been very courageous, believe it or not, and sent quite a few questions to our questions, which I'm going to look to my left if you see me looking that way. So I'll go ahead and ask my presenters to turn yourselves back on. And I will start with the easy one. Will attendees get a PDF of the slide decks? The question was asked, excuse me. Yes, we'll post a recording of the PDF slides on our website. So rest assured that if you missed anything, or if you have any additional concerns or want to use some of this data, we can go ahead and look at our website and it'll both be posted there. So Shawn, you want to stop sharing too. Second question, I'm going to go ahead and ask you, since you just got done reading it directly. Embedment versus adhesion. I've seen that on some other presentations. Now, Shawn, why do I care about this? And if you've just answered that, I apologize, but I read the question directly off the screen. Shawn?
So in embedment and adhesion, you can look at are really two different things. Embedment to me means more of how well that chip is set into the asphalt binder you've got. To me, adhesion is going to get in a little bit more of the polymer and things like that. They're going to help keep it from coming out, where you have that elasticity in that asphalt is going to help keep that adhered better to the binder versus the embedment is more, to me, more of a depth type of a question.
Sweet. Anyone else? Otherwise, I've got quite a few to plow through. Why don't I direct this one to my two first presenters? The myth, does latex polymerization retard chip seal cures? Arlis, do you want to handle this one, then hand it to Aaron?
Sure. I'll go ahead and start it off. In the past, there has been that myth that the latex systems are slower to cure than the modified asphalt base chip seal systems. I think it's kind of gone back to the warmer temperatures in the middle of summer because of the way that Aaron described how the differences in the system. The polymer modified asphalt basically grab the chip a little better in hotter pavement temperature roads. But with the emulsifier systems now and with the way the latex systems are, these systems are designed where they're very similar. And I think that it's kind of just a myth now. That's not saying that, you know, whether you run a polymer modified system, you know, sometimes it may cure a little slower. Sometimes latex system may cure a little bit slower, but either one can perform very well, and it's not because of the type of polymer that you run in the system.
Sweet. Aaron, you okay with that? Still muted, sir. Well, little technical difficulties. Why don't I go ahead and share a question and answer while we figure this out. Just thank you from Cody. Just sharing an update on the timber bridge deck that Bobby mentioned. Surprising, the rubber chip seal on the timber bridge deck is now 10 years old. It's held up very well, but recently started to delaminate. At this point, the bridge is scheduled for a large rehab project, so we did some spot repairs, but it held it together until then. Thank you. Speaking of Bobby, I would love to ask this question. Chip seals at times are politically messy, with chips flying around and piling up in the gutter or ditch. Bobby, is there any evidence that hot applied chip seals reduce this risk?
So you will still have, chips. At the end of the day, it is the chip spreader out there, and you will have that. What you do get, and what typically, kind of reduces some of that political blowback, is that you have that sweeping immediately. So you don't have the typical period, and I know different parts of the country are a little different. Some where they are sweeping emulsion-based chip seals same day, but I think a lot of the country still has where the emulsion chip seals are being left for multiple days before being swept. That's where a lot of that loose stone, and again, as you mentioned, the gutter line outside the wheel paths, you end up with that. With the hot applied chip seals being able to be swept same day, you greatly reduce a lot of that and the political blowback that comes with it. Again, it is still a chip seal. You do still have some of that, but it is significantly reduced with the same day sweeping.
Thank you, sir. On a hot topic, going back out to Kansas City, does the size of the chips reduce the windshield claim? I wasn't totally listening, well, pretty honest there. But 3/8 chips are standard in my state, but in town, we've been redirected to reduce the size to 1/4. Does it matter? Shawn?
It can. And in my experience, here around the Kansas City area, we're actually very blessed to have an expanded shale product we use for chip seal. And so it's very lightweight in nature, and you can go up pretty large in size and not have any windshield issues. But if you're dealing with a hard, durable stone, a granite, very hard limestones, things of that nature, I found that switching from that from the 3/8 down to a 1/4 inch does significantly reduce the amount of mass when it comes to those individual chips. And although they can and will, occasionally fly up and hit a windshield, that 1/4 inch one is just not heavy enough to be able to break that glass or chip that glass. Whereas we found that the 1/2 inch, especially, and even a 3/8 size, I think it just comes down to what it weighs and what it's capable of. So yeah, we have here in Missouri, they don't do a lot of chip seal on very, very high volume roads without using a 1/4 inch chip. They really reduce that size down to prevent that, and it has made a significant impact.
Cool. I'm going to throw this one to everyone because I don't have one, but is there a cost difference between latex and polymer modified emulsions? I'm going to throw that one to anyone because I don't know who to ask. Anyone? Someone?
Yeah, I think it would just depend on the area that you're in, Phil. I think that's the costing basically in those agencies that have latex and polymer modified asphalt, both the prices are competitive and comparable. So I think that's probably the best way to answer that. Obviously with the asphalt and haul, it varies, but I think they'll get comparable pricing.
Cool. Thank you. Any proposed solutions to the group on handling the destruction and chip loss associated with trash truck, delivery trucks, and larger vehicles turning in cul-de-sacs? One of my favorites. I'm going to throw it to Shawn first since you're my contractor, and then anyone else after that, please chime in. Shawn?
I know we've got an agency here in town, and we typically do between 300 and 400 cul-de-sacs for them every year, part of a pretty large project. And switching to that smaller stone, they generally use a 3/8 stone everywhere on the project, except for the cul-de-sacs. We isolate those, treat those different. Kind of goes back to a little bit what I was saying there with we have to design, for the normal just driving traffic versus design for something that does have very tight turning traffic. You're recycling trucks, trash trucks, every Amazon truck that goes through there 14 times a day, everything like that. And the biggest impact we've been able to have is by reducing that stone size smaller, to where it seems like it's just less likely to roll or less likely to move. And I've had pretty good luck doing that.
I think absolutely Sean's spot on with that. I think the other part is when you get into larger vehicles, turning areas, stopping areas, I think those are kind of the areas where you get into a lot of the similar type issues, as Sean mentioned. It is that balance of what the application rate is to the stone size and trying to match that up. It kind of goes back to, again, the flushing comment that Sean brought up earlier. And that's certainly something that there is sometimes a very fine line when you get into certain situations. So I think it kind of goes hand in hand with the question and trash trucks and cul-de-sacs and that is balancing out the application rates, the amount of liquid that's there as well with the stone.
Cool. Anyone else? A question from my partner to the state to the east. For hot applied chip seals, how much asphalt binder is used to pre-coat? And the question went off the page. Well, that was awkward. Pre-coat the aggregate, forgive me.
So typically it's the specification that's out there, and the AASHTO specification is 0.4 to 0.8 gallons per square yard. Simply that half a gallon is about right. When you start getting closer to a gallon, it gets messy, and you kind of get too much and start getting into the balling. So somewhere in that 0.5 to 0.6 is kind of the sweet spot typically.
Wonderful. I have one more until you guys keep typing. Sean, you mentioned chipping on the freeways. Do you happen to know what the ADT was? Oh, more questions. Sean?
The last time we did one for the state of Missouri, which was this summer, I believe we finished it in early June, I believe, late May, early June. It's about 35,000 cars per day is what they saw on that one up there. It's a stretch of I-35 that we did.
North of Kansas City?
Up there towards Iowa, up there towards the state line.
Cool. And then a follow-up question. You mentioned there are some other considerations when considering chips on freeways. What would those be, Sean?
It may be cure time. You want to make sure you give that as much time as possible, just given the amount of traffic. We try to do those earlier in the season versus doing them in the middle of the summer when pavement temperatures might reach 140, 150 degrees. We try to get them down when it's a little bit cooler out to try to help keep that flushing at bay. And also because we typically are doing edge to edge in the interstate, treating that shoulder separately. That it's not the same project when you're talking about a shoulder with no traffic versus a road with 35,000 cars. So that really needs to be considered.
Cool. This one I don't know who to direct it to, so I'm just going to read it out loud. Hot applied chip seals and chip seals in general, has been enough time to apply a longer design life for a hot applied chip seals versus typical? And I'm going to throw an additional answer, latex versus polymer. Who wants to field that little gem? Otherwise, I'll sign it.
Okay. Sorry, can you throw the first part of that again?
Sure, I'd love to.
Right.
Hot applied chip seal : has there been enough time or observations to apply a longer design life versus a typical chip seal?
So I'll start with that. Hot applied chip seals have been out there for decades. I know here in the Northeast, it's over 25 years that they've been applied. So certainly there is enough, both field data and as well. There was a section at NCAT that looked at that, and more research has kind of been done on it. So it's continuing to evolve in terms of the materials, because there have been, and I think we have a few folks on here from out in California, where there's been some different stuff done over time and some of the mandates at different times. But in general, yes, there certainly has been enough usage over the last several decades to be able to see what you're getting for life out of them. in relation to the emulsion-based chip seals.
And I'll comment about the latex versus polymer modified. BASF has eco-efficiency studies that were done years ago that compare the materials, and they basically have been compared to have identical lifetimes on the same roads. Obviously, as Shawn mentioned, you have to put them down on the right roads in order to get a good comparison. And as Bobby mentioned, the NCAT test track has also verified these applications and how the performance has been very good. And so from that standpoint, whether you use a polymer modified base or a latex modified chip seal, they've performed very similarly.
I actually, if I could, Phil, as well, just to add one thing, because I know I mentioned, and Arlis just mentioned it as well. A plug for the NCAT Min-Roads work and that research and the amount of data that's out there. Being able to look at all types of applications, chip and other, from the preservation side of the performance and that. So certainly, if folks haven't checked that out, I think it's pretty well out there, but always want to recommend that to take a look. And I think the follow on to that being, and Shawn covered it really well in terms of the expectations, because that's one of the great things that they did with that research with NCAT Min-Roads is to look at the pre-existing condition and how that impacts the performance of the treatments.
And I'd also give a plug for the combination treatments, Bobby, that they've done on the NCAT, where whether you'd have a chip seal followed by a microsurfacing, call it cape seal applications, and how much they extend the life. So some of those go beyond just the chip seal, but there's great information there in both areas.
Wonderful. Well, I will say quite bluntly, it has been truly an honor to be part of this discussion with the four of you. I have learned quite a bit, and I've done this for almost 28 years now. So I really appreciate the time that you've taken this morning. And furthermore, well done. People, you've sent me some good questions. I'm really excited about that too. I've got two final comments because not really questions. Let me go ahead and read them for you. One, Michigan DOT fogs their chip seals. Seems to give some performance. I've never done that in Missouri. And then finally, and the one I want to end with is construction practices, as you guys have also said, drives the quality of the product just as much as the engineering put into it. So with that comment, I'd like to throw it back to Mr. Green to lead us out of this particular webinar. Mr. Green?
All right. Well, thank you. As Phil said, thank you to our panelists. Thank you to all the attendees. For those of you that are on the East Coast, I know we're eating into your lunchtime, but I appreciate you hanging out with us. In closing, again, don't forget, keep your eyes open for an email for our January 18th roundtable discussion. Again, hopefully good dialogue back and forth. And then February 15th of 2024, we'll be back here for another Skillshare webinar. No specific topic decided yet, but I'm kind of leaning towards learning a little bit more about mastics, but I'll see what my planning committee has in mind, and we will go from there. As always, thank you, everyone. Thank you, panelists. Thank you, Phil, for the great job that you did moderating. Thank you, all the attendees. If you have any other follow-up questions, please reach out to the National Center, to me, to any of the panelists. Like Phil commented, we will have the presentations and this recording and the slide decks available on the National Center's website. If you have not ventured over there, please look that up. A lot of great information. With that, I will let everybody go. Thank you very much again for your time. Enjoy the rest of your day and the weekend. Thank you.
Want to take us back into panel mode?
I don't know that we can do that, Phil, once
Okay.
we've started it.
That's okay. I just want to make sure everybody felt comfortable with what we did. I know we're still being recorded. Go ahead and take this out of it. But I felt pretty good. I appreciate you guys' time.
No problem. Thanks, everybody.
You have a great day. I'm going to go outside. It's still pretty nice out.
Sounds good.
Thank you again, everyone.